Alright, so today I'm going to show you how to construct a prediction model where the response variable is numerical variable using the Boston housing data. So we try to predict the median house value given the feature of the house. Okay, so let's get started. So in order to doing that, we first of all gonna insert the source node right here. We're gonna insert that gonna Excel data file. So we have a Excel node, and then we locate to the data source right here, the Boston housing data set. First of all, we will read the data and to see any problem with that. So you can see right here the number of number of variables in the data set gonna be 15%, 15 variables. There all the name the variable on top right here, and this is a target variable or response variable. We want to predict the values. Okay, so let's get started with the next step. Okay, so the next one we're gonna insert the type node. Go to the field operation right here, and we insert the type node right here. So we click the type node and we read the data. So we can see right here the chart that's gonna be categorical variable where it distinguish the house have the border or doesn't have the border with the chart river. Okay, so this is a categorical variable. This one also, this is the basic, also the categorical variable. That's a different version or categorical version of the median house value right here. Also we change the row of the variable. That's gonna be the target, and right now we don't use this variable, so we select none. On other variable we just consider as the input, apply, and okay. So that's the setup for the variables. Next one, we want to partition the data into two subsets. The first subset is for training or construct our model. The second one we use to evaluate the model. So in order to doing that, we gonna insert the partition node right here. Okay, so double click right here. We're gonna have the two subsets, the training and the testing or validation data set right here. I'm gonna using the percentage, it's a 60 and 40. Okay, so now the number of records or percentage of records gonna be used for training the 60% and 40% number of records for testing or validation. Apply, and need to read it. So basically this node gonna insert one more field or one more variable. That's a partition right here. We have the categorical variable. Yes, have a name for records with the training or testing right here. How to select the records in the data right here, gonna based on the random seed right here. That's gonna be generate a random number to select the records in the data for the training and for the testing. Okay, so so far so good. We're gonna continue with our constructing model. So now we knowing that the after the partition right here we have the one subset the data for training and another subset for evaluation of the model. So the model I want to use just the linear regression model. I'm gonna using this one. So now we have the target variable right here and on the predictor right here as the input. We also have some option right here. So the objective right here, we can create the standard model, or you can have some other option, enhance the model accuracy or model stability, or create a model for very large data set. Okay, let's go with the standard one. We have the model selection right here. So now we have several input variables. We can use the forward stepwise to select a best subset of the data, or also we can use the best subset algorithm to select the best subset of data for prediction. So let's say we select the include all the predictors in this example. We use the mean for the combining rule, advanced, and yeah. So that we're gonna in that default. Let's run the model to generate the nugget of the model right here. So just click right here. We can see now the model have been constructed. The first model summary right here, the target that the numerical we want to predict the values, automatic data preparations on, and this information criterion you to select different subset of the variables. So this information right here, smaller is better. Okay, so look at this one, that's accuracy. So right now you can see using the adjusted R-square right here is gonna be 0.77 4. So that's gonna be the so basically the adjusted R-square values are larger the better. That's indicating how much the information gonna be, or the variance of the response variable can be explained by the predictor. Okay, so now you can see right here the accuracy around like 77%. So actually that's the exact number right here, 77.4%. This is good number, but not a excellent predictor right now. Okay, and we can show different approach to improve the accuracy of the prediction. Next parameter showing the output right here, that the automatic data preparation. So they can see some of the transformation of the variable, some trim the outlier to improve the accuracy of the model. So this one, this is automatic preparation. The next one right here show the predictor importance. You can see right here the room is the most important one with the very high scale factor right here. That makes sense because from the previous video we can show that the strong relationship or correlation between the median house value and the room variables. So this makes sense in this model. And also we have the PT ratio and LS state and so on. Okay, so they are ranking from the most important to the least important of the input variables. The next one they're gonna show the a scatter plot between the actual value of the median south value and also the predicted right here. So basically, if you have a good prediction model, this one gonna be a very strong correlated. This gonna be straight like that. This one is a good model for predicting the median south value right here. You can see some scatter right here, and but also you see that the pretty strong correlation between the predicted value and also the actual value right here. Also, we can have the residual of the predicted value right here. So basically, the residual should be a normal distribution. This one not perfectly, just some peak right here, but that's just gonna be the same with the observation of the good model we saw from the previous parameter. Okay, we have right here that the outlier for the processing of the outlier. And this one more interesting. This showing the effect of the different variable to the performance of prediction. So you can see right here, room transform are gonna be have most impact to the performance, and so on. It's ranking based on the importance, as we saw before. Now it's kind of graphical representation where the ticker and a line right here gonna indicating the impact more to the performance or the response variables. Right here, using different color to indicating the linear regression model, where the blue line right here gonna be positive coefficient, and the orange right here is gonna be a negative coefficient. Okay, so this one gonna be showing the estimated mean of the response variable, and also the predictor. Okay. You can see right here. All right. So in order to get more information, we're gonna insert a analysis node right here, and you see we're gonna run. Right, just let the default value right here and see. All right, so by running just the analysis node, you can see that the training and the testing information right here. The mean error right here gonna be negative 13. This is the order of 8,000, so 13,000, and this is 10,000. Maximum gonna be 27 and 32. The mean we expected gonna be around 0, so where the positive and negative gonna cancel out, so that means 0. This one is the important one. That's the mean absolute error, so smaller the better performance of the model. This one around 3,000, and also this is 3.46,000. So this one, as we discussed before, that's the a good model, but not an excellent model. And this one linear correlation. This one correlation between the predicted value and so the actual value right here. So 88. 0.88, so that's pretty good or strong correlated between the predicted and also the actual value right here. This is smaller because this is the validation data, so as we expected, it's gonna smaller compared with the training data right here. The last one right here is just the total number of records in the training and this in the testing. Okay. If you want, we can also insert a evaluation graph to see the leap chart of the gain of the predictor of the performance. Okay, so we just use the default right here. We also include the baseline, so the perfect predictor or the perfect model compared with our model to see how good is that our model compared with the best model. Right here you can see with the training right here, the predicted our model here is pretty good compared with the perfect right here. So there's some error right here, but the constructed model is do pretty good in terms of predicting a median half value. This is the testing of validation data. It's performing a little bit lower compared with the training right here, but you can see the compared with the perfect model, that's also did a good job in terms of predicting the median half value. Okay. All right. So that the linear regression model in predicting the median half value. I want to introduce a very powerful node in modeling the data mining in this task. So basically, we can use the automatic numeric right here. Okay, so let's insert this one. So basically, this node right here gonna be include a multiple model, and by using this one, they gonna run multiple model at the same time, and then gonna select the best one right here. So you can see that the number of model we're gonna use, we gonna be a 3 best model in there, and based on the testing partition right here. Just let using the default right here. Expert right here, you can see a list of a possible model we can use for this task. So you can use the KNN, also you can use the support vector machine as well. Okay, so let's select all of them in model. So we rank by the correlation between the predicted one and so the actual one. Okay, the higher gonna be saying that the predicted one very close to the actual one. With the time node setting, so it means the target variable gonna be median sound value, and also the only answer one gonna be the input or the predictors. Okay, let's run it. So they're gonna run us through all of the model and construct the nugget right here. So let's click right here. You can see once the nugget created, they gonna ranking the and select the best 3 model in there. So you can see the neural network right here is gonna be the best with the correlation coefficient right here is 0.884. Okay, this one 0.84. This is 83. So this one gonna be the best, where the coefficient between the predicted value and so the actual value is very strong and very high. Number of field or number of predictor is 13, and the relative error gonna be 0.22. And the other one increase a little bit compared with the best model right here. Yes, gonna quickly showing the scatter plot between the actual value right here and also the predicted value right here. You can see a pretty strong correlation between the predicted and also the actual value right here through this scatter plot. Yeah, you can see the scatter plot right here between the actual value and also the predicted value right here, the same right here. But here you can see the predictor importance right here. So basically you can see room also the most important predictor for the median sound value. The next one gonna charge that's the categorical variable. So this is gonna determine related to the house have the boundary with the chart river or not. Okay, so this we see that from the data exploration, we see that chart variable also is very important to in determining the house values and so on. Okay, so you can see ranking from the most important to the less important right here. This one pretty interesting right here. The ranking is lower than the other one compared with the linear regression we saw before, right? So that the model right here. So we also can see the other one right here. This is KNN. That's the K nearest neighbor methods right here. That's some spread in the high value sound right here. So it's mean in this range is the prediction is not as good at the lower range of the median values. All right. So maybe then we want to have more detail. We can insert the input right here with the analysis node right here to see more detail right here. So we can before doing that, we're gonna remove the you can use the background right here as a neural network. All right, and then we gonna using the analysis node and just see what the performance. Right here, as you can see, basically the training and so the testing right here. The mean error kept the same as before. This one a little bit lower compared with the previous one. The important parameter right here, you can see this one significant reduced compared with the previous one right here. Let's come back right here. And the so the around 3,000 and 3.46,000. Okay, it's much larger than this one right here, just about 2,000, and this one 3.9 thousand. Okay, so this is smaller compared with the linear regression. We can see that this one is pretty strong here, 0.9. That's the almost perfectly correlated between the predicted one, also the actual value here. This one also 0.88. Right, so this is also very very good performance of the predictor, the median half value. The number of records will be the same as before. So basically that the how do we construct the model, building a stream for predicting or estimating the numerical variables. So that's it for this video. The next video I'm gonna show you how to construct a stream to classify a categorical variable. And thank you, and I'm gonna see you in the next video.